everyone, welcome back. Now we're still here at the College of Engineering and we're talking to more student groups that are working on some amazing innovations. So now we're here with Amen and he's going to tell us about 3-4. Take it away.
All right. Hello everybody, my name is
Hey Eamon, what about the ingredients here?
Yeah, why don't we just burn it like the rest of things?
Well, hey guys, you want to be careful with that kind of material. This stuff is actually really valuable.
Valuable? Just trash, look at that.
Hey, wait a second. My instrument's made of plastic. Are you calling it trash? Wait, that's a great idea. Why is anyone doing this?
Well, tell you guys the truth. We're the ones doing this. My name is Eamon Carmen. I'm a junior in material science engineering, and I'm the student president of the Reform program.
I'm Matthew Hines. I'm a junior in industrial engineering and I'm a treasurer of the Reform program.
My name is Haley Schultz. I'm a junior in material science and engineering, and I'm the lab coordinator of the Reform program.
My name is Alex Thayer. I'm a junior in material science and engineering, and I'm the head of the recycling and filament extrusion team here in Reform.
I'm Abby Freimuth. I'm a junior in music education, and I won the Dash Innovation Contest for composition.
All right. So, what are we trying to do here at Reform? Well, our goal is to turn plastic waste consumables like this into musical instruments and instrument parts. And we want to do that through the lens of technology like extrusion and other polymer processing techniques, and combine that with 3D printing. The goal of our program is to reduce waste, yes, but more importantly, we want to educate everybody here at Iowa State about what really all goes into recycling plastic. Why is it so difficult?
We chose to use music because everyone loves music, and also it's a great way to get the community involved.
Music is a challenge. Creating a musical instrument is a functioning musical instrument is a challenge, but it's a challenge that can be seen, heard, and felt. If we can 3D print a musical instrument, we can 3D print anything.
So just to give you a bit of an overview of our program, we got to start with where we are now. Right now we're actively developing material science solutions that will work to help us get this recycling aspect of our program done. We're going to talk to you about that in detail. We're tirelessly networking with other departments and with the Architecture CCL Lab, where we're relentlessly learning about professional skills and polymer processing, and we're fiercely resourcing money, people, time, and places. Now, through the investment of time of our members and through the investment of our sponsors, we want to grow this program into, we want to acquire more resources and et cetera, start actually doing what we want to do, which is to evangelize recycling and really get the word out on, what all goes into this process. And through that, we want to build sort of flagship technology where we can just drop a plastic bottle in to a machine, and then that will come out as a printed object, an instrument program. Now, just to show off quick what we've done so far, Abby Freimuth is going to play a little bit of something on a 3D printed operator. That up in just 5 minutes. That was beautiful. Thank you so much, Abby. All right. Now, I'm going to pass it over to Alex. He's going to be talking about our technical process.
Yeah, so let me walk you through, as Eamon said, our technical processes. It's a really cool idea of just turning recycled plastic into a 3D printed instrument like this. But let me walk you through some of the steps that actually go into it. So first, our first challenge is the collection. We need to establish an infrastructure here on the Iowa State campus and the Ames community, and hopefully beyond that as we scale up, to actually bring in and collect a volume of plastic that we can use to make many 3D printing instruments like this. Next, we have to go through a sorting process for them. So, if you look at just a simple plastic water bottle like this, there's actually over 7 different kinds of plastic that can be involved in just this one water bottle. And the thing about these different kinds of plastic is they are not compatible with one another in terms of printing and creating filament to print with. So we need to establish a system that we can effectively and efficiently sort this plastic into its respective identities. Next, we need to clean this plastic. We need to get rid of any impurities that might present a challenge to the actual creation of the filament. So then we need to establish a way that we can do this efficiently. What's a process that we can do this effectively and efficiently, as I said? So the next step is our grinding. So once we have this clean plastic waste, we need to grind it up into small, little pellets. Kind of like this. And the reason we need to do this is a couple steps down the line. When we put our plastic waste into a filament extrusion system, it needs to go through without jamming it. So it needs to be these small particles. And additionally, we need to make sure that these small particles are pure. Once again, removing any of those impurities. Now, an essential step that a lot of people before us have overlooked, and that's caused a failure, is omitting a drying step. So, the reason we need to dry is certain plastics, like PLA, polylactic acid, like what this is made of, actually adhere to moisture very well, and when that moisture is heated up with the plastic, there can be a chemical reaction that occurs that weakens and degrades the plastic, making it unable to be used. So, we need to figure out how long and what temperature we need to do this at so we can effectively repeat each process. So the next challenge we have is the actual extrusion of the filament itself. So this is turning these small ground particles, like this, into a round filament that you can put into a 3D printer. But this also comes with its own challenges, including what temperature we need to heat the extrusion system to. What screw speed? How fast do those particles need to go through the system? The feed rate, how quickly do we actually feed those granules into the system in order to create a consistent filament diameter of 1.75 millimeters, which is the industry standard for all 3D printers. Next is our spooling process, where we take that extruded filament and actually make it and wind it up into this spool. But it's not as simple as it sounds. There are certain factors like the cooling and the pull rate, which can significantly affect that filament diameter and make it unable to be printed with. So, once again, we want to create that smooth, uniform filament that we can then use to 3D print things like this. So that's our final step, is the printing. It's really exciting, and we're making a lot of progress with coordinating with the architecture department at their computation and construction laboratory, where we made this chess piece, and very recently, this 3D printed ocarina. Over the course of 6 weeks, we went from their 20% recycled plastic blend filament to 100% recycled PLA to successfully print both this chess piece and this musical instrument. And the reason that they were having so much trouble before, over the course of 2 years of work getting to that 20% recycled plastic, was simply because they didn't quite have that grasp of how different factors influence the polymer blends that we're talking about. So, over the course of 6 weeks, we made it happen.
Great. So thank you all so much for presenting today. I know that we're winding down on time, so we will have to be able to provide this presentation elsewhere too, so that way everyone can have access to it. I want to ask you all 2 questions. Well, actually 1 question. Give me 2 words to describe the collaboration and your collaboration style with one another. I know you all are some dynamic innovators, unique skill sets. So how would you describe the collaborative effort that resulted in today's presentation and all of these amazing innovations?
One word that comes to me immediately is explosive. When we started getting together, I mean, the ideas just kept going and going and going. We were able to quickly develop what we have today, just because we have a lot of perspectives.
Thank you so much. What about you? 1 word.
It's been a lot of fun. I think I just started as fun. We've had fun throughout the whole process, and we're going to keep having fun and creating new ideas.
Great. Thank you all so much today for your time today. I can't wait to see how this project goes out into the world. Thank you for creating here at Iowa State University. We'll be back with more student presentations from the College of Engineering in a few moments. See you soon.